So, quick review on characteristics of functions review. Here you go. I'm going to zoom in. Before I get started with the questions that they give us, I'm going to read this function here, and I'm going to go from left to right. So pay attention. Here it goes up to the screen. From left to right, if I was to read this graph or this function, the graph starts there, or the function starts here. And then, what do you say? It goes what? Up. What's another word for up? Increase. Then all of a sudden it hits the highest point, and then all of a sudden it starts going down. What's another word for down? Okay, then it hits the lowest point, and I'm going to go back up again, which means what? Increase. Okay. So with that said, first question. On what interval is the function decreasing? When they're talking about this, they're usually talking about the domain or the x value. Look at it. On what interval is a function decreasing? Talk it over to your neighbor. Let them know between what two values is it decreasing, please. Let's see. Brianna, between what two values is the function decreasing? Five, you said? And what else? 13. One of those numbers is correct, which is this one. Help her out with the other end, guys. Tell the your neighbor, where does the other one start decreasing? Miguel? 3. Let's see if it's true. I'm going to get my highlighter, and I'm going to use my pink one. You said 3. Starts there, and all of a sudden it starts decreasing. And it stops right there. Hands up, do you agree that's where it decreases? Yes, that is correct. How do we write that in interval notation? Tell your neighbor, please. Interval notation. Bracket, because it includes the point. 3, comma, 13. That is correct. How do we write that in set notation? Now, be careful, because now instead of x, what are they using? What variable? T. Tell your neighbor what would be the set notation, please, for that. All right, let's see. Colton, go. Solution set of T such that. Hands if you got that. That is correct. So, think about it. Look at the graph given. If this is where it decreases, tell your neighbor the sections that it increases. Tell your neighbor the sections that it increases first. And then give them the x values or the t values. Once you have it, I want you to write it in interval notation and set notation, please, for both. Okay, Victor, give us one section that increases. 18. Just that? Oh, 13 through 18. 13 through 18. Hands if you agree with that? Yes, that is correct. That's one section. So how do we write that in interval notation, Victor? Hands if you agree with that. That is correct. How about set notation? Help us out, Noah. Help him out, Monte. Okay. Next section. Who can give me the other section? How about Cindy? The second section that increases. 0 to 3. Hands if you see that part. Yes? All right. And how do you write that in interval notation? Okay. And set notation for that, Danica? Okay. Show me your fingers. I'll come through you with this again. It's coming back, right? It's just a quick review of what we did last week. Okay. Next, I want you to write a note somewhere over here on the side. I want you to write min or max is when the function changes direction, direction from up to down, or increasing to decreasing, or from down to up. Minimum or maximum is when the function changes direction from up to down or from down to up. You're saying, all right, so let me go back to the graph that we just did. We started with increasing, yes? Did it change direction at this point? Yeah, so I'm going to place a point here. This is what we call the max. And what is that max point? 3 of x. What is the y value? 2.5. Then it decreases. However, what happens at this point? It changes direction, doesn't it? It goes back up, so this is the next point right here. And this we will call what? The minimum. And what is the coordinate for this one? 13, 0.75. Okay, we good? All right, so that was number 2. We're done with number 2. Let's go to number 3. All right, let's see if we can do this part without highlighting anything. I already showed you how to highlight for domain, right? We highlight from where? Bottom to the top and going from left to right till the function ends, right? So, what would be the domain for the entire function? Talk it over to your neighbor. And interval notation first and then set notation. Domain for the whole thing. Tell your neighbor, please. All right, let's see. Jasmine, domain and interval notation. Zero to 18, but we write it as bracket 0, comma, 18 bracket. Hands if you agree with that? Yeah, because it covers all the way from here to right there. And what's our set notation? Set notation, solution set of t such that 0 less than or equal to t, less than or equal to 18. All right, I'm going to switch to blue. Now I need to find the range. Remember, for the range, we start highlighting from the bottom up, the lowest point to the highest point of the function. Imagine that you highlight, tell your neighbor between what two values of v, now it's v, it's no longer t, do you find, question? For the domain, because we're talking about the entire function. We're not just talking about the decrease. We're looking at the entire function. Where does the function start? Here, and it keeps going, and it ends over here. So we're talking about the whole thing. Okay. So neighbor, the between what two v values do we find the range for the whole function? All right. Kayla, go. Between what 2 points? Kayla. 0.75 and 3. 0.75, comma, 3. Thank you, Caleb. Set notation. Fernanda. Solution set of V all right. Yes. Show me the films. How come you are with these? 5, 4, 5, 4, 5, 4, 5, 4. Yes. So you need to get a manicure or something. Anyway, let's move on. Yes. All right. Here we go. Our objective for today: I can transform a function using different parameters. I can transform a function using different parameters. What concept are we still on? Functions. That is correct. So you're writing your objective. Now the prayer model, I want you to fill that in by yourself tonight with your family. Make it a family math night. You're like, gather around, everyone. We're talking about functions. I can see you guys with your cousins. Imagine, that would be fun, right? Okay. Anyways, so yeah, you fill that in by yourself. Somehow you should know by now the definition, example, non-example, and hashtag, yes? All right, what is the one thing that you notice on the objective was different? Parameters. Don't copy this, but what are parameters? Parameters are a number that transforms a function into another function. Parameters are a number that transforms a function to another function. For example, I'm going to put it in day-to-day terms. Let's say I said, okay, the weather's getting better, so I'm going to start running every day for the next 7 days. So on the first day I run in the morning, I run a mile. So I'm probably going to finish the mile. On the second day, I run a mile again. On the third day, I run a mile. Fourth day, mile. Fifth, sixth. Every day I run a mile. So I bring and I tell that to one of my students, and I noticed one of my students in the first period, she's in track. And she's already practicing. Guess how many miles she runs every day? 6 miles. Gabby's running right now 6 miles in the morning. So I said, what? I'm barely thinking about 1 mile. You're thinking about, so you're telling me for 7 days you're running 6 miles every day? So yes, 6 miles. So think about this. Mine was every day, how many miles? 1. And she just transformed my function into 1 every day running how many? 6. So that number that it changed, that's what we call a parameter. When we change one thing to a different thing. That's called a what? Parameter. We're going to see that in action in a little bit, okay? But before we do, let me go to my PowerPoint. Write your pencils down, look up. Here we go. When we started graphing two variable equations, I'm going to go and go step by step to make sure I don't lose some of you, because this is where it starts getting funner. Let's go. Here it goes. If I ask you to graph this using a table, I usually ask you to write domain -2, -1, 0, 1, and 2. So your table would look something like this, -2, -1, 0, 1, and 2. And how do you get these values? Well, we substitute these values for x in here. So what is 3 times -2? -6 minus 1, -7. Next value, what is 3 times -1? -3 minus 1, -4. What is 3 times 0? 0 minus 1, -1. What is 3 times 1? 3 minus 1, 2. And the last one, 3 times 2 is 6 minus 1, 5. Are we there so far? But what did we say when we started with function notation? We said that instead of writing y, what would we write? So what would this look like? F of x equals 3x minus 1. And everybody understands that it's just a label. Is that correct? All right. So what would the table look like if we were writing in function notation, everyone? Instead of y, what would we write? That is correct. And the same values for x, same values for y. Does everybody see how we got these values? Now, why is it called f of x? Because what we're saying is that we're going to do a function to whatever x is. So if I bring x in here, then it's going to become what? F of x. Therefore, the next one would be what? F of -2. But then we apply it here, and that gives us this number. That's what the f means, that it's creating a function to whatever the number they gave us for x. Okay? So, I'm going to stick with this one. Here it goes. So let's say I take this. I'm going to transform this f of x to something else. So I'm going to add an extra column here. There it is. Write your utensils down, look up to the screen. Here it goes. First of all, is this f of x? No. This column's f of x. So what are you saying? That -7 is f of x? Yes, Mr. Q. How about -4? Yes, that's f of x. How about -1? Yes, that's also f of x. How about 2? Yes. And 5? Yes. So what is this one telling us? Don't say it out loud. This is saying that f of x plus 5. So if I'm here, think about it. Talk it over your neighbor, let them know what would I write right there once I do the transformation. All right, let's see. Who said -2? Let's find out why. What is this saying? F of x plus 5. What is f of x at this point? -7 plus 5 is -2. Tell your neighbor what we would write in this cell, please. Everyone. 1, that is correct, because f of x is what? -4 plus 5 is 1. Next one. What is f of x? -1. So what goes here, everyone? That is correct. Next one, f of x is 2. What goes here? And the last one, 10. So I see this because to me, math to me, I love math and it's easy for me to see. However, I don't like this presentation. So I'm going to have you do an activity so we can present it differently so you can see where we get each piece. Because that's some of the pieces that the book doesn't show. So on your graph paper, turn your paper over. In the back at the top left, I want you to write example Q. Graph f of x equals 3x minus 1 using the domain -2, -1, 0, 1, and 2. Write that down. So, if we were to make a table using this, all these are x values. Is that correct? All right, so then your table would look like this. Yes? Okay, make that table. Also, next to that, I want you to copy this table. The first transformation. Notice that the x values are the same. We're just writing the transformation that we're going to do. And underneath that, I want you to copy this next table, which is in red. So we have a table in black or in pencil, a table in green, and a table in red. Copy those, please, and we'll get started in a little bit. So, all right. So, let's fill out the one in black first, or the one in pencil, because that's our starting function. -2, when we substitute in here, is 3 times -2 is -6 minus 1, that's -7. Oh, sorry. -7. Next value. -1 times 3 is -3 minus 1, that's -4. 0 times 3 is 0 minus 1, that's -1. 1 times 3 minus 1, that's 2. Alan, how did it go? 2 times 3, that's 6, minus 1, that's 5. Are we there so far? All right, before we graph, let's fill out the other one. So now check this out. For those of you that kind of missed it, here it goes. This is saying f of x plus 5. So when x is 2, here's 2, what is f of x? -7 plus 5, -2. That is correct. Next value, -4 plus 5, 1. -1 plus 5, 4. +2 plus 5, 7. And 5 plus 5 is 10. All right, let me help you with the first value of the red one. There it goes. This is f of x minus 2. What was our first f of x here? Oh, let me change the color, sorry. -7. What is -7 minus 2? -9. Next value, what is -4 minus 2? -6. Next value, -1 minus 2 is -3. Next value, 2 minus 2. And the last one, 5 minus 2, that is 3. All right. Let's graph the first function, the original function. Here we go. -2, -7. -1, -4. 0, -1. 1, 2. And 2, 5. Graph your line, make sure it goes all the way across. There it is. And we're going to label this one, look up, right here, label it f of x. F of x, that's our first one. Next, let's graph the green one. The green one. Switch colors to green. -2, -2. -1, 1. 0, 4. 1, 7. And 2, 10. All right. So graph your line, make sure it goes through all the points. Now look what I'm going to label the new one. Look up, please. Look up. since it's a new transformation, anytime you do a new transformation, you have to relabel it to a new function. It can no longer be just f of x. Now we're going to label this one g of x. And that's going to equal to, what did we use for transformation on that one? F of x, what else? Plus 5. That is correct. That's our new function. Don't graph the red one yet. Just, we're going to focus on these two for right now. Okay. Okay, writing utensils down. Look up to the screen. You'll finish copying right now. Look up. Look up, please. Look up. Let's say I took all of you outside and I had you do this line like this and formed you guys in this line. But I specifically picked 5 people for the 5 points that I did. Are we there? What directions would you tell the rest of the class to do to create the new transformation? Talk it over your neighbor. What directions would you tell your neighbor, because you're making that line, to do in order to create the new transformation? Who's got it? Aria. Close. Sit to the left and then something else. But let me now focus just on the 5 people. Look up. Here's one person. Here's another person. Here's another person, another one, and another one. Now this person is here. This person is there, 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 and there. Tell your neighbor what directions you're going to tell that person to do from the original to the new one. Clarissa, what would be the directions? She said 5 steps up. That way. Let's see. From here, 1, 2, 3, 4, 5. From here, 1, 2, 3, 4, 5, and so on and so forth. Hands if you see that. Okay, now look at the function and the transformation of the function. Look up. What do you notice here? Therefore, before you graph the red one, tell your neighbor and make a prediction what's going to happen to the original function now with this transformation. Pedro, what did Cindy say? Oh, you didn't hear? Cindy, what's going to happen? Two steps down. Hands if you agree with that. All right, so if that's true, I don't want you to use the table. I want you to transform this into the red one using this at each point. Go. Don't use the table. Go with the graph. All right. Let's see. Who did this? 2 down, 2 down, 2 down, 2 down, and 2 down. Therefore, our new transformation will look something like that. Hands if you got that? Yeah? And what would we write that our function to be on this one? Once again, if it's a new function, we write what? G of x equals to what? What was the transformation? F of x minus 2. That is correct. Let's go. Show me your fingers how confident you are so far with that. Got some 5 4s, 5 4s. Okay. Let me forward your screen. Look at that one. Lock your toolbar. And I want you to graph the green transformation of that function. Yeah, on the iPad. You don't have to do it on paper. On the iPad. You got 30 seconds. Ready? Go. All right. Now, there's a general rule of what we just did. Write that down. G of x equals f of x plus k. G of x equals f of x plus k. Question and hint. In the objective, I said that whatever we did to the function was called something. So what do we call k, everyone? What do we call k? Parameter. That is correct. Parameter. And if you were to explain it to your BFF that wasn't here, what would you explain k does to a function? What would you explain k does? Talk it over your neighbor. What would you explain k does? Okay, make a little note for yourself. So I heard some of you, if it's positive, it moves the function up, and if it's negative, it moves the function down. Does that make sense? Yes, it's cute. All right, good. Okay. Go to your graph paper and copy this one, please, on the next coordinate plane that you have underneath. Example super Q. And then it says graph f of x equals x squared using the domain -2, -1, 0, 1, 2. And I gave you the 3 different tables. This is going to go pretty quick, so everybody go like this. Bear with me. Yes? So let's see, as we are writing the first table, the rule is x squared, yes? So what is -2 squared? 4. What is -1 squared? 1. 0 squared? 1 squared? And 2 squared? 4. Okay. Let's plot that. -2, 4. -1, 1. 0. 1, 1. And 2, 4. Nice and curvy like mine. There it is. Okay. Looks like a dog, doesn't it? Like the 2 eyes and the nose. No? You guys see it? No? All right. All right. Writing utensils real quick. Down. Look up to the screen. I'm going to block this one for right now so we can focus on this one. Who notices that the green one now, the -5 is not outside of the parentheses? It's where? Inside. So what does that mean, Mr. Q? Well, here we would substitute -2 in here and do something to it at the end, yes? But this one, instead of substituting the -2 in here by itself, now it's -2 minus 5. So what is -2 minus 5? Here it goes again. -2 minus 5 is -7, yes? And what is the rule? Square it. So what is 2 minus 7? What is -7 squared? 49. Next one. What is -1 minus 5? -6. What is -6 squared? 36. 0 minus 5? -5. What is -5 squared? 25. What is 1 minus 5? Negative 4. What is negative 4 squared? 16. What is 2 minus 5? Negative 3. What is negative 3 squared? 9. I'm going to give you another value, 3. What is 3 minus 5? Negative 2. What is negative 2 squared? 4. Another one. What is 4 minus 5? Negative 1. What is negative 1 squared? 1. And the last one, 5. What is 5 minus 5? 0. Okay, let's plot those points. So we can't plot 49 or 26 or 16. Can we plot 2, 9? Yes, 2, 9. 3, 4. 4, 1. 5, 0. Hold on. Let's finish this off really quick. Now, if I gave you more values, you would get this. Look up. Okay, hold on before you pack up. Look up, please. This is the original one, and this is a new function. Tell your neighbor what happened to the function when we did this transformation. And move to the what? To the right. How many steps? 1, 2, 3, 4, 5, because it's what? Negative 5. So question. What's going to happen to the original function if it's plus 4? It moves to the what? Left. That is correct. All right. Log out, please. There is tutoring today. If I don't see you guys tomorrow. And once again, the home play is right there. Have a good one, guys. Bye.